Welcome. In this video, we are covering everything you need to pass the Red Hat Certified Engineer exam, the RHCE EX294. This is an Ansible automation exam, and every single task is hands-on. We'll go through architecture, inventory, ad hoc commands, playbooks, roles, collections, vault, templates, and troubleshooting. This is your complete study guide. Let's go. Let's start with the exam itself. The RHCE exam code EX294 is a performance-based Red Hat exam. Like the RHCSA, there are no multiple-choice questions. You sit in front of a live RHCL9 environment and complete Ansible automation tasks. Either the system ends up in the correct state, or it doesn't. Click the exam covers 6 domains. Playbooks and core concepts at 30%. This is the single largest domain. Roles and collections at 20%. Variables, facts, and templates at 18%. System administration tasks at 17%. Managing users, packages, services, SE Linux, and storage through Ansible. Vault and security at 8%. And troubleshooting at 7%. Look at the exam details. Exam code EX294. You get 4 hours, more than most Red Hat exams. The passing score is 210 out of 300, which is 70%. The prerequisite is RHCSA. You must hold a valid RHCSA before registering for the RHCE. The environment is RHEL9 with Ansible Core 2.14. Click the pie chart makes the priority clear. Playbooks, plus roles, plus variables. Those top 3 domains together account for nearly 70% of the exam. Know them deeply. Before writing a single line of YAML, you need to understand how Ansible actually works. This architecture diagram shows the complete picture. There is a control node, the machine where Ansible is installed, and where you run your playbooks. Inside the control node, you have the CLI tools, Ansible, and Ansible Playbook. You have your inventory that defines the managed hosts. Your playbooks written in YAML. The Ansible.cfg configuration file. Ansible Vault for encrypted secrets. And your collections and roles installed via Ansible Galaxy. To manage nodes are the actual RHEL servers you are configuring. Look at how the control node connects to them. Pure SSH. No agent. No daemon on the managed side. The managed node only needs 2 things. SSH access and Python installed. Docker agents, Chef clients, configuration daemons. None of that. Just SSH and Python. This is Ansible's killer feature. You can manage thousands of nodes, with 0 installation on any of them. Click the component table at the bottom. Memorize these definitions. A module is an idempotent unit of work. A task is a single module call with arguments. A play is a set of tasks targeting a group of hosts. A playbook is a file containing 1 or more plays. A role is a reusable structure of tasks, variables, templates, and handlers. A collection is a redistributable bundle of roles, modules, and plugins. Let's get Ansible installed and configured correctly. The exam environment has it pre-installed, but you need to understand the configuration layer. DNF install Ansible Core Manj. That's it on RHEL9. Ansible batch version shows you the installed version and the Python interpreter it's using. The project directory structure shown is the pattern you should always use in the exam. Everything under one project directory. Ansible.cfg in the root. Inventory/subdirectory for hosts files and group_vars/ host_vars/ for host-specific variables. Roles/ for your custom roles. And vault/ for encrypted secret files. This structure is self-contained. The project local Ansible.cfg takes priority, and everything is relative to the project root. Ansible.cfg, walk through the key settings. Inventory points to the hosts file. Remote_user is the SSH user Ansible uses to connect to managed nodes. Host_key_checking equals false disables host key verification, standard in lab and exam environments, where you're connecting to new VMs for the first time. Forks equals 10 controls parallelism, how many hosts Ansible works on simultaneously. _escalation, become equals true means every task uses sudo by default. Click SSH key setup, generate a dedicated key for the Ansible user, then SSH copy AD to all managed nodes. Then run Ansible all manping. If every host returns pong, your connectivity is perfect and you're ready to start. Next, the inventory is the foundation of every Ansible project. It defines what hosts exist and how they're organized into groups. The INI format is the most common and readable. Ungrouped hosts go at the top, named groups in square brackets. The web service group contains 3 web hosts. B servers has 2 database servers. Production. Children creates a group of groups. Production contains web servers, DB servers, and load balancers. You can target production, and all hosts in all 3 child groups respond. Host level variables go inline. web3.example.com. Ansible_port equals 2222 overrides the SSH port for just that host. Group-level variables in web servers vars apply to every host in the group. The YAML format is preferred for complex inventories. It's more readable when nesting gets deep. Same logical structure, different syntax. YAML inventory files also compose cleanly with group_vars and host_vars directory structures. Click group_vars and host_vars. This is how you separate variable data from inventory structure. A file named group_vars/webservers.yml automatically applies to every host in the web servers group. A file named host_vars/web1.example.com.yml applies to exactly that one host. Host vars override group vars for that host. For example, nginx_port 8080 in the host vars file overrides the nginx_port 80 from the group. Click inventory patterns, know all the operators. : for union web servers, DB servers matches all hosts in either group, and for intersection web servers, and staging matches only hosts that are in both web servers and staging. For exclusion, web servers, DB1 matches all web servers except DB1. And tilde for regex, tilde web 0-9.example.com uses a regular expression. Next, ad hoc commands run a single module against hosts without writing a playbook. They are essential for quick checks, one-off tasks, and exploring what facts a host has. The syntax is Ansible target pattern, menfee of module, a arguments, then options. The common options: menfee for become, sudo, -v through -vvvv for verbosity, check for dry run, diff to see what would change in files, beat, walk through the examples, Ansible all, mping, the health check, always run this first. Ansible web servers, -v, command, a uptime, run a command on all web servers. Note command versus shell. The command module is safer. It does not use a shell, so no pipes, redirects, or glob expansion. The shell module runs through /bin/bash and supports all shell features. Installing a package, Ansible web servers, -mdnfa name equals nginx state equals present, -v. The -b flag is critical here. Package installation requires root. Starting a service, -m service, a name equals nginx state equals started enabled equals yes. Creating a user, -m user, a name equals alice state equals present groups equals wheel. The setup module is special. It collects all the facts about a host. Ansible Web 1M setup dumps hundreds of variables: the OS, IP addresses, CPU count, memory, disk layout, kernel version. Filter equals Ansible_distribution times, narrows it to just the distribution related facts. This is how you explore what variables are available before writing your templates. Click the fetch module goes the other direction. It copies files from managed nodes back to the control node. Ansible Web 1M fetch-a src equals /var/log/ninx/error.log dest equals ./log/flat equals yes. Flat equals yes avoids the default behavior of creating a directory named after the host name. A playbook is a YAML file containing one or more plays. Each play targets a group of hosts and runs a sequence of tasks. Understanding the structure is the most important skill in this exam. Look at the playbook shown. It starts with 3 dashes, that is required YAML document notation. Then the play starts with name. The host's key targets the web servers group. Become. True enables sudo for all tasks in this play. Gather _facts. True tells Ansible to run the setup module before the first task, collecting all Ansible_facts. Beat. The execution order within a play. Pre_tasks run first, before roles and tasks. Then roles run. Then tasks run. Then handlers run. But only the handlers that were notified by a task that changed something. Finally post_tasks run. This ordering matters. Use pre_tasks for bootstrap activities, like ensuring Python is present. Beat handlers are the key concept to understand deeply. Look at the notify. Restart nginx on the template task. When that task results in a file change, it queues the restart nginx handler. The handler only runs once, at the end of all tasks, even if 3 different tasks notify the same handler. And it only runs if at least one task that notified it actually changed something. If you deploy the same config twice in a row, the second run detects no change, no notify fires, and nginx is never unnecessarily restarted. Click Running Playbooks. Syntax check costs nothing, and saves you from wasted time on YAML errors. Check is the dry run. It models what would happen without making changes. Check diff is the dry run plus file content diffs. Limit restricts execution to specific hosts or groups. Start at task picks up from a specific task name, useful when rerunning a failed playbook after fixing an issue. Ansible ships with hundreds of built-in modules. For the RHCE exam, you need to know about 15 of them deeply. Let's cover the ones that appear on every exam. Ansible.builtin.dnf, package management. State, present installs. State, absent removes. State, latest updates to the current version. Pass a list of package names to install multiple in one task, far more efficient than looping. Ansible.builtin.service, controls systemd services. State, started ensures it's running. State, restarted stops and starts. State, reloaded sends a reload signal. Enabled, true creates the systemd symlink for boot. Combine both in one task. State, started and enabled, true simultaneously. Ansible.posix.firewalled. This module has a subtlety that catches candidates. Using permanent, true alone writes to the firewalled config, but does not apply immediately. Using immediate, true alone applies now, but does not survive a reload. For the exam, always use both together. Or use permanent, true and then add a separate firewall cmd reload command task. Ansible.builtin.copy copies a file from the control node to managed nodes. The backup, true option keeps the previous version as .backup before overwriting. Ansible.builtin.template is like copy, but runs the source file through the Jinja 2 template engine first, substituting variables, running loops, evaluating conditionals. Use validate to run a syntax check command before deploying. nginx-tc%s aborts the task if the config is invalid, protecting you from deploying broken configs. Click Ansible.builtin.lineIn file ensures a single line exists in a file matching a regex. Regex identifies the existing line to replace. Line is the replacement. If no line matches the regex, the line is appended. Ansible.builtin.blockin file manages a labeled block of multiple lines. The marker system ensures Ansible can find and update the block on subsequent runs without duplicating it. Next, variables in Ansible have a well-defined precedence order. Understanding it is essential for writing predictable playbooks. Look at the pyramid. At the very bottom, lowest priority, are role defaults defined in roles/myroles/defaults/main.yml. These are intentionally easy to override. Moving up, inventory group vars, then host vars, then play vars, then task vars, then set_fact and registered variables. At the very top, highest priority, are extra vars passed with the E flag on the command line. Extra vars always win. Use E to override anything for debugging or one-off runs. B to practical implication. Put baseline values in role defaults / put environment-specific values in group_vars / put host-specific overrides in host_vars / put sensitive values in vault files loaded as vars_files. This layering means a playbook works equally well in dev, staging, and production, just by having different group vars files. Beat Ansible_facts. Built-in facts gathered by the setup module. The ones you'll use constantly. Ansible_hostname for the short hostname. Ansible_fqdn for the fully qualified domain name. Ansible_distribution for the OS name. Ansible_distribution_version. Ansible_default_IPv4.address for the primary IP address. Ansible_processor_vCPU count. Ansible_memtotal_MB for total RAM. These go into templates to generate host-specific configuration automatically. Click Register captures a task's output into a variable for use in subsequent tasks. Look at the example. Register, disk_result captures the output of the dfh/command. Then disk_result, stdout is the raw string, disk_result, stdout_lines is a list, disk_result, rc is the return code, disk_result.change tells you if the task resulted in a change, disk_result.failed tells you if it failed. Use failed_ when to define custom failure conditions, based on the registered output. Next, Jinja 2 is the templating engine embedded in Ansible. Any file processed by the template module is run through Jinja 2 before being deployed. Understanding Jinja 2 is what separates copy-paste playbooks from real automation. The three delimiter types: double curly braces, variable substitution and expressions, percent braces, %%, control flow, if statements, for loops, hash braces, hash, comments, stripped from output, beat filters transform values, upper and lower change case, default, fallback, provides a fallback if the variable is undefined, join, turns a list into a comma-separated string, length, gives the count, int and boolcast types, password_hash, SHA-512 feet, hash is a password, you will use this for the user module, base name and dir name extract parts of a path, beat, look at the full Nginx, conference J2 template example, line by line, Ansible_managed is a built-in Ansible string that says, "This file is managed by Ansible, do not edit manually." Ansible_processor_vCPUs sets worker processes to the actual CPU count of each target host. The same template generates the right config for a 2-core dev VM and a 32-core production server. Nginx_keep_alive_timeout, default, 65, uses a default filter. If Nginx_keep_alive_timeout is not defined anywhere, 65 is used. Click the upstream backend block is the most powerful part. % for host in groups, web servers %, loops, over every host in the web server's inventory group. Host vars, Ansible_default_IPv4 feet, addresses accesses the facts of another host from the current host's template context. This is how you auto-generate a load balancer config that includes every web server's actual IP address and updates automatically when you add or remove a host from the inventory. Conditionals and loops are what make playbooks dynamic, handling different OS versions, optional steps, and lists of items. When the condition must evaluate to true for the task to run. The most common use, checking the OS distribution. When Ansible_distribution = Red Hat, this task only runs on Red Hat systems. If you're managing a mixed fleet of RHEL and Ubuntu, you can use a Jinja 2 inline ternary to pick the right package name. Apache 2 feed if Ansible_OS_family == Debian, else HTTPD. When you need multiple conditions, list them under when, that is an AND. All conditions must be true for the task to run. For OR logic, use a single when with the OR keyword. When Ansible_distribution == Red Hat, or Ansible_distribution == CentOS. Using register with when is extremely powerful. Check if a file exists with ansible.builtin.stat, register the result, then use when, not config_file.stat.exists, to only create the config if it's missing, a clean idempotent pattern. Beat loop iterates over a list. The current item is available as item. For a list of strings like package names, the loop is simple. For a list of dictionaries, like the user's example, item.name, and item.groups, access the keys. The shell default for item.shell default /bin/bash means if the shell key is missing from a user dict, bash is assumed. Click loop_control customizes loop behavior. Label overrides the default output. Instead of printing the entire item dict for each iteration, it prints just the item's name. Index_var gives you a loop counter starting from 0. The dict2items filter converts a dictionary into a list of key-value pairs that you can loop over, used when your variable data is a dict and you need to iterate it. Next, real systems fail. A good Ansible playbook handles failures gracefully, rather than leaving systems in a half-configured state. Ignore _errors. True is the simplest form. The task may fail, but execution continues. Use it for genuinely optional operations, like stopping a service that may or may not be running. Failed when defines a custom failure condition. The disk usage example, failed when, disk_usage. std out int greater than 90 makes the task fail if disk usage is above 90%. Without this, the shell command would always succeed, exit code 0, even when the disk is full. Changed when defines when a task should report as changed. The diff example returns exit code 1 when files differ. Normally that would be treated as a failure. Setting failed when, diff_result. RC greater than 1 means only codes above 1 are failures, and changed when, diff_result. RC == 1 reports a change only when the files actually differ. Beat block/rescue/always is Ansible's try-catch finally. The block section contains the happy path, install ngix, deploy config, start service. If any task in the block fails, execution jumps to rescue, which logs the failure and attempts to revert to the backup config. The always section runs regardless of whether block succeeded or rescue was needed. Use it for notifications, cleanup, or status reporting. Click handlers and notify. The key point is that handlers run once at the end of the play, not immediately when notified. If you need a handler to run in the middle of a play, for example, restart Apache before testing the config, use ansible.builtin.meta flush_handlers. This forces all pending handlers to run immediately at that point in the task list. The URI test in the example then confirms the service is responding correctly before the play continues. Next, roles are the primary way to organize and reuse Ansible automation. Every significant piece of configuration, Nginx, a lamp stack, user management, hardening, should be a role. Look at the directory structure diagram. The roles/nginx/directory contains 8 subdirectories. Tasks/main.yml is the entry point. This is what Ansible executes when the role is included. Handlers/main.yml contains the handlers. Template/holds Jinja, two template files referenced with just their file name. Ansible finds them automatically. Files/holds static files for the copy module. Defaults/main.yml has low priority default values. Vars/main.yml has high priority role variables. Meta/main.yml declares dependencies on other roles. And test/ contains the test inventory and playbook. BD. The default/versus-vars/distinction is crucial and heavily tested. Variables and defaults/main.yml are the lowest priority. They can be overridden by inventory vars, group vars, play vars, or anything else. This is intentional. Defaults are documented baseline values that users are expected to override. Variables in vars/main.yml are high priority. They override most other variable sources. Use vars/for internal role values that should not be changed by users. BD. Look at the tasks/main.yml shown. Every task uses the fully qualified collection name, ansible.builtin.dnf, not just DNF. Every task has a tags key. Tags let you run only parts of a role. Ansible playbook site.yml. Tags install runs everything tagged install across all plays and roles. Ansible playbook site.yml. Skip tags debug skips debug tasks in production runs. Click meta/main.yml. Declares role dependencies. Dependencies. Role. Common means the common role always runs first before this role. Using roles in a playbook, list them under roles. You can also pass role-specific variables in line with the role, key, and vars, block. Next. Ansible Galaxy is the community hub for sharing roles and collections. Ansible Galaxy is the command line tool for consuming that content. For roles, Ansible Galaxy role install gearlingguy.ngnx installs into ~.ansible/roles/ by default, or into /roles/ if you set roles_path in ansible.cfg. Pin a version with a comma, gearlingguy.ngnx 2.8.0. This is important. Unpinned roles can silently break when the author releases a new version. Beat-requirements.yml is the right way to declare all dependencies in one file. Separate roles and collections sections. Specify versions for repeatable, production-grade automation. Run Ansible Galaxy install -r-requirements.yml and Ansible Galaxy collection install -r-requirements.yml to install everything. In CI/CD pipelines, this is how you bootstrap a fresh runner with all dependencies. Beat collections are the modern packaging format. They bundle roles, modules, plugins, and documentation together under a namespace. The format is namespace.collection for the collection and namespace.collection.module_name as the fully qualified collection name, FQCN. Always use FQCN in production playbooks to avoid module name collisions and make the source of every module explicit. Click the RHEL system roles collection is exam relevant. redhat.rel_system_roles provides certified, Red Hat supported roles for common RHEL administration tasks, ×YNC for NTP configuration, network for network interface management, SELinux for SELinux state, storage for disk and LVM management, and firewall for firewalled rules. On the exam, if a task says, configure storage using system roles, this is what you use. Next. Let's walk through a complete production quality user management playbook. This is a common exam task and it combines several modules. Start with the group module to ensure groups exist before creating users that reference them. The loop over wheel devs ops creates all three groups in one task. Beat the user module. UID. Assign a specific UID. Groups. Supplemental groups. Append. True. This is critical. Without append, Ansible replaces the user's supplemental groups with the list you provide. With append, it adds to existing groups. Password_update. On _create, only set the password when creating the user, not on every run. Without this, every playbook run resets the password, even if the user changed it themselves. The password field uses the password_hash filter. P at SSW0RD. Password_hash. SHA 512 feet. SALT 1 foot. Never store plaintext passwords in playbooks. Always hash them, and always put real credentials in vault files. Beat ansible.posix.authorized_key. Manages SSH authorized keys. Lookup. File. Reads the public key file from the control node. Exclusive. False adds the key without removing existing ones. The line in file task for sudoers uses validate. vsudo -cf%s. This runs vsudo against the modified file before saving. If the sudoer's syntax is broken, the task fails before writing to disk, preventing you from locking yourself out. Beat. User removal with state, absent and remove. True. The remove flag deletes the home directory and mail spool. Without it, the account is deleted, but files are left behind. Storage management through Ansible covers two approaches: the RHEL system role for declarative LVM management, and individual modules for lower-level control. The storage system role is the cleanest approach. Define a storage_volumes list variable. Each entry specifies a name, type LVM, which physical disks to use, the volume group name, size, file system type, and mount point. Apply the redhat.rhel_system_roles.storage role, and it handles everything, creating the PV, VG, LV file system, and FSTAB entry in the correct order. If you extend the size in the variable and rerun, it extends the LV and grows the file system online. Beat. For more direct control, the community.general collection provides LVG for volume groups, LVOL for logical volumes, and file system for formatting. These map closely to the VG create, LV create, and MKFS commands you know from the RHCSA. Beat Ansible.POSIX.mount manages FSTAB entries and mounting. The state value controls exactly what happens. Mounted, mount it now, and add to FSTAB. Present, add to FSTAB only, don't mount yet. Unmounted, unmount, but keep in FSTAB. Absent, unmount, and remove from FSTAB. Click the community.general.parted module manages partition tables and partitions. State, present with a label creates the partition table. Then add a partition with the number, part_start, and part_end parameters. Swap management mkswap, swapn, and then add via the mount module with fs type, swap and ops, sw. Next. This slide shows a complete LAMP stack deployment playbook that combines packages, services, firewall, and SE Linux, all the moving parts that appear in exam tasks. Look at the variable design. Packages and services are lists. The same task loop handles any number of items. Firewall_services is separate because the firewalled module has different syntax. This separation keeps the task list clean and makes the playbook easy to adapt. Beat. The DNF task uses the list directly, name, packages. Passing a list to DNF is more efficient than looping. Ansible batches it into a single DNF install transaction. The service loop iterates over services, and both starts and enables each one. The firewalled loop uses immediate. True, because we want the ports open right now, not after the next reload. And permanent. True, because we want it to survive reboots. Beat. The SE Linux tasks are what many candidates miss. Ansible.POSIX.SE Boolean, with persistent true, equivalent to setcbool. Pages must have persistent, true, or the Boolean resets on reboot. Community.general.sef context registers the context rule in the SE Linux policy, equivalent to cmanage fcontext, not a. Then the separate restore contask applies it to existing files. This two-step pattern is the correct idempotent approach. Click DNF module streams. Community.general.dnf_module with state enabled selects the stream. Then ansible.builtin.dnf installs from it with name, php 8.2/common. The cron task uses the ansible.builtin.cron module. Specify minute, hour, user, and the job command. The systemd timer example shows how to deploy both unit files from templates and then use the systemd module's daemon_reload. True option to trigger a daemon reload without a separate command. Next. Ansible Vault solves the fundamental problem of storing secrets in version-controlled playbooks. Using AES-256 encryption, Vault-protected files are safe to commit to Git. The Vault commands create opens an editor to write a new encrypted file. Edit decrypts to a temp file for editing and re-encrypts on save. View decrypts to std out. Encrypt converts an existing plaintext file to encrypted. Decrypt goes the other way. Use carefully, as this produces a plaintext file. Rekey changes the Vault password. Beat encrypt_string is particularly powerful. It encrypts a single value that you can embed inline in an otherwise plaintext variable file. The output is a Vault YAML tag, followed by the encrypted blob. Your vars/main.yml file can be committed to Git as plaintext, with only the password values shown as encrypted blobs. This is the most readable Vault pattern. Beat running playbooks with Vault. Ask Vault pass prompts interactively. Vault password file ~vault_pass reads the password from a file, essential for CI/CD, where there's no human to type a password. The password file must be shmode 600. Ansible checks this and refuses to run if the file is world readable. Click no_log. True is the equally important counterpart to Vault. Vault protects the variable at rest. No_log. True prevents the variable from appearing in Ansible's task output, which goes to logs, to std out, to CI job output. Any task that uses a sensitive value, copying a private key, running a command with a password argument, add no_log. True. Click multiple vault IDs, let you use different passwords for different security domains. Production secrets with one password, dev secrets with another. Label them with vaulted prod at prompt, and run with multiple vaulted flags. The label is embedded in the encrypted blob, so Ansible knows which password to use for each value. Next, the troubleshooting domain is only 7%, but the skills are used in every other domain. When something doesn't work, you need to diagnose it efficiently. The decision tree shows the systematic approach. Start with syntax errors. Ansible Playbook. Syntax check catches YAML indentation problems, wrong module names, and missing required arguments. This costs nothing, and should be your first step before every run. Beat. Connection errors. Ansible all, mping is the diagnostic. If it fails, troubleshoot SSH directly, with SSHV user at host, to see exactly where the connection is failing. Check key permissions. ~.ssh, authorized _keys must be 600. The .ssh directory must be 700. If permissions are wrong, SSH silently ignores the key. Beat module errors. Run with moduv vvv. 3 V's gives you the full Python traceback, and the exact arguments that were sent to the module. Ansible doc, less than module greater than shows the full module documentation, all parameters, their defaults, and examples. It is always available in the exam environment. Read it freely. Logic errors. When the task runs, but the result isn't what you expected, the debug module is your tool. Debug. var. My underscore variable dumps the current value of a variable. Debug. var. Host vars, inventory underscore hostname, dumps everything Ansible knows about the current host. All facts, all group vars, all host vars, all registered variables. Click. The verbosity levels are a gradient. Native v shows task results. Native vv adds file operation details. -vvv adds connection information. Which SSH user, which key, which port. Native vvvv adds the full SSH debug output. For most issues, native vvv gives you enough. The test strategy. Run with check diff to preview changes, then limit host 1 to test on a single host before running against the group. Next. This slide shows a production quality playbook that brings together every concept we've covered. Read it top to bottom. The play targets web servers, becomes root, and loads a vault file for secrets. Variables define the package list, username, document root, and TLS certificate paths, all in one place at the top. The pre_tasks section runs a DNF update _cache with changed _when false. This ensures the package cache is fresh without reporting false positives on every run. Beat tasks are organized logically with comments as section headers, packages, user, SSL, configuration, file system, SE Linux, firewall, service, verification. Tags on each section allow you to run. Tags configure to only repush configs without reinstalling packages. The SSL private key task uses ansible.builtin.copy with content vault_SSL_private_key to write vault encrypted key material to disk. No _log, true is on this task. The private key must never appear in output. Mode 0400, only root can read it. Beat, the template task has validate, negrinex tc%s. Ansible writes to a temporary file, runs the nginx config test on it, and only overwrites the real config if the test passes. If your template has a Jinja2 error, or you reference an undefined variable, the validation catches it here. The C Linux section, Boolean with persistent, true, then cef context to register the policy, then command, restore con to apply it. 3 steps, always together. Beat, the verification section at the end uses ansible.builtin.uri to make an actual HTTP request to the server. Retries, 3 and delay. 5 give the service time to come up after the reload handler fires. Until web_check.status in 200, 301, 302 retries, until a successful HTTP response is received. If the server never responds, the play fails with a clear error. The final debug task reports the hostname and status code, confirmation that the deployment succeeded. Next, let's talk strategy and the commands that should be muscle memory by exam day. The one-liners block. These are the commands you need to run without thinking. Ansible all-mping to verify connectivity before starting any real work. Ansible Playbook, syntax check before every run. Ansible Playbook, check, diff to preview. Ansible Playbook, -e, key equals value, to override a variable on the command line for quick testing. Beat, the vault one-liners, Ansible vault create and encrypt _string are the two you'll use most. Encrypt _string for individual values, create for entire files of secrets. Always run playbooks with vault password file pointing to a file with the vault password. Typing the password interactively every time is slow and error-prone in a 4-hour exam. The Galaxy one-liners, Ansible Galaxy role init to scaffold a new role, Ansible Galaxy install-r requirements.yml to install all declared dependencies at once. Don't install roles and collections one by one. Beat. For inventory debugging, Ansible inventory graph vars is the most useful single command in the exam. It shows you the complete inventory hierarchy as a tree, with every variable value that each host will see. Run this when your playbook is using the wrong variable value, and you can't figure out why. Click Domain Focus. Playbooks plus roles plus variables together are nearly 70% of the exam. If you only have limited time to practice, focus there. System admin tasks at 17% is where the RHCSA knowledge comes back in, but now you're automating it with Ansible modules instead of running commands manually. Click the practice checklist. Work through every item. Write the Ansible.cfg from scratch. Build the inventory with group vars and host vars layers. Write a multiplay playbook with handlers and notify. Build a role with Ansible Galaxy role init, and use it. Create a vault file and reference it with vars_files. These are the exact task types you will face in the exam. Repetition builds the speed you need. Next, the mind map shows the complete RHCE skill tree. 8 branches radiating from Ansible at the center. Fundamentals, playbooks, data, control flow, roles, collections, and system tasks. Every branch connects to the others. Templates use facts. Roles use defaults and vars. Vault protects data used in system tasks. Click 10 rules for exam day. 1. Ansible.cfg first. Before writing any playbook, configure inventory, remote_user, become, and vault_password_file. Without a correct Ansible.cfg, nothing else works. Click 2. Syntax check before every run. Free error detection. Always. Click 3. Check diff to preview. Verify what will change before you commit. Click 4. FQCN always. Ansible.builtin.dnf, not DNF. Ansible.pulsix.firewalled, not firewalled. FQCN avoids ambiguity errors and is required for collection modules. Click 5. Ansible doc is your friend. The exam environment includes full module documentation. If you forget a parameter, look it up. It's faster than guessing. Click 6. No_log. True on every task that touches passwords or keys. The marker of a security-conscious Ansible user, and it's tested. Click 7. Permanent. True and immediate. True for firewalled. One without the other is incomplete. Click 8. Persistent. True for Boolean. Without it, the Boolean resets on reboot, and the task fails after verification. Click 9. Validate. In template and copy tasks for config files. Prevent deploying broken configs that take services offline. Click 10. Test ID impedency. Run your playbook twice. The second run must report 0 changes. If it doesn't, fix it. Idempotency is the fundamental Ansible contract. A correctly written playbook can be run any number of times safely. Next. And that is the complete RHCEEX 294 Ansible Study Guide. Every domain, from architecture and inventory through playbooks, roles, vault, and troubleshooting. Set up your 5-node lab, work through that practice checklist, and run every playbook twice to confirm ID impedency. The RHCE rewards preparation. 4 hours is generous if you know what you're doing. If this video helped, please like and subscribe for more DevOps and certification content. Good luck on the exam. See you in the next one.